Hi, my name is Stuart Lynch, and in this video we're going to dive into closures to really try to understand what they are and how to use them in Swift. We'll start by understanding the closure syntax and simple closures. And we'll follow that by seeing how we can use closures as parameters in our functions, and we'll understand what trailing closures and escaping means. We'll also look at how closures are used in SwiftUI all the time. And we'll finish by looking at creating functions that can return closures and how closures can capture values. But before I get started, please make sure that you leave a comment below if you enjoy the video. Give it a thumbs up and subscribe to my channel. Also, make sure you ring the bell to be notified of new videos. So if this is something you want to learn, then keep watching. Closures in Swift are so important to understand. I consider it one of the most important concepts for aspiring developers to get a handle on, so buckle up and let's get going. As I often do, I have created a starter playground here with 4 different pages to keep us focused. There is a shared function in the public functions file in the playground sources folder that itself is a function with a closure whose purpose is to keep our code separated so that the printouts to the debug window can be identified by example, and so we can reuse functions and variable names without conflict. You may not understand this syntax now, but by the end of this second page of this playground, you should. And there's also another playground ViewModifier here that we'll use so that we can apply a SwiftUI canvas to one of our playground pages. Swift lets us use functions like any other type, such as strings and integers. This means that you can create a function and assign it to a variable. And you can call that function using the variable, and even pass that function into other functions as parameters. Functions used in this way are called closures, and although they work like functions, they're written a little differently. The simplest kind of function in Swift is one that has no parameters and executes directly without returning anything. Like this one here. And calling the function executes the code within the braces. Well, this function can also be expressed as a closure. A closure is a self-contained block of functionality that can be passed around and used in your code. So let's do that. Let's first create a variable, and it can be a constant, so let's call it sayHelloClosure, and assign it a block of code. And we do this by using a pair of braces to represent the code block, and between the braces we can enter our code. Well, it's the same code that we would use with a function that has no parameters. We execute the code the same way as executing a function. Now, before we move on, let's talk a little bit about what it means to refer to the type of an object that is a closure. In Swift, we can do things like this. I'll create a constant called x and assign it the value 5. If I option click on x, I see that it has inferred that x is an int. Now, even though Swift is a statically typed language, meaning that the type of every property, constant, and variable that we declare needs to be specified at compile time, it supports type inference. It infers by the fact that 5 is an int that x will be an int, so we don't have to specify the type explicitly. If I change 5 to 5.0 and check again, we see that Swift is now inferring x as a double. Now, what if we wanted to enter just 5, but have it infer that it's a double? Well, you can't. Swift can't read your mind, so you'll need to manually override the inference with an explicit type specification. Now, I said that every property, constant, or variable we declare needs to be specified at compile time. So what type is sayHelloClosure? Well, if I option click on it, we see that it's the type that looks like this. And what this is saying is that our closure is a function with no function parameters, returning nothing, which is the same as our sayHello function. So we could have been explicit and defined our closure like this. Now often you'll see instead of returning this 2 empty parentheses, it'll return the word void. Either way is fine. Moving on then, let's take a look at a function that does have a parameter, like this one in this example. The body of the function uses the parameter within the print statement. So how do we create a closure that will do this? Well, we'll start with our basic closure like this. Let's say hello closure equal, and then set up our two braces. But how do we pass in our argument to the body so that we can print out hello Stuart, or whatever name we pass in with our closure? So let's assume for a minute that Swift could infer that our function is going to get a string. And we can give it a name for that string, like name. Well, in a closure, you specify that name at the beginning of the body of the closure, and then follow it with the word in. And then your block of code follows that, like this. Now I get the error. I'm unable to infer the type of closure parameter name in the current context. As I said, Swift can't read your mind. It can't infer what type the thing name is. Now, we know it's a string, so how do we tell our constant say hello closure here that that's what it is? Well, we can be explicit in two different ways. The easiest way is to attach the type to our name variable right in the body where we create our variable name. We can then execute the closure like this, where we pass in our string as an argument for the closure. Well, this works, but when we're dealing with trailing closures, as you'll see later, sometimes it's better to be explicit when we are creating our closure variable. Let's option click on Say Hello Closure now to see what type it is. And we see that it's a closure with a string parameter that returns nothing. So we can remove our type annotation for the parameter from the body and assign the full type at the declaration stage, like this. Now let's consider this function then that has two parameters, a and b, and they're both ints that return an int. And the int that is returned is the sum of those two numbers. To see what this result is, we'll assign it to a constant and then print it out. So let's create a closure called sum closure that'll do the same thing. So I always start with setting up a variable or a constant and my parentheses. Well, now I have a choice. Now I need to make sure that Swift understands what my types of A and B are and possibly what the type is going to be returned. So in the body, I'll need two variables. I'll call them A and B. I'll use then the word in following as we did before. And then in the body, I'll return just the A plus B. Now I need to decide how I want to let sum closure know what those values are, what types they are. And so what I can do is provide a type for each of the arguments, like this. We're specifying that both A and B are ints, but nowhere do we specify that the type is that's going to be returned. And this is where Swift gets smart again. It now has enough information to infer that the return type is also an int, since A and B are both ints, and when we add them together, it can then infer that the return type is an int, so no need to be explicit here. Well, we can assign the closure to a constant like the closure answer, provide two int values for the closure, and then print it out. Now, if we option click on our variable, we see that it is a closure now with two int parameters, and it returns an int. So if I remove the type annotations from our closure variables here, we can specify that complete type annotation for sum closure. And of course, now in Swift, if our closures return a single line of code, we can remove that return keyword. Closures in Swift are just as legitimate as a string, an int, or any other type. we can use them as parameters in our functions. So for example, let's create a function called sayHello that has two parameters. One that is the name of a string, and the second one that is a closure that is of the type that has a string parameter and returns nothing. Now in the body of our function, I'm going to create a new name that is the first name in all caps, and then use the capitalized version that is the argument for our closure. Now when I call this function, sayHello, I need to provide an argument for the name as well as for the closure. So for the first argument, I'll use my name, but what about the second? Now let me try to show you how there are different ways to handle this. Since we see that finally sayIt is a closure with this type, we see that we can write our closure directly, just as we did in the previous playground. Now we see that Swift is getting an indication that our closure is expecting a string and returning nothing, so it knows the type. So we'll call it name, and then because we're in a closure, we use the word in, and then we can write our code block in our function. If we execute this playground, we see that it works just as expected. So let's comment out this code now, though, and write it a different way. And this is probably the most common way to deal with closures when they are the last argument in a function like this. It's called a trailing closure. We'll start the same way, but this time I'm just going to hit enter on the second placeholder. Our argument name disappears and the closing parentheses is added after our first argument, and then the braces start with a placeholder for the closure's argument. And so we can start to write our body now as long as we give some name for our string placeholder. So we'll call it name, just as before. And we'll do the same print. Well, this is how you will most likely deal with trailing closures, and why you often see other YouTube presenters do what may look like voodoo magic to you when they're entering their code, and you wonder what they're doing. If we comment this out right now and copy in option 1, this is what is actually happening when you tap enter on a trailing closure. The closure name is removed along with a comma separating the arguments before the trailing closure, and the parentheses is moved up from the end to close off the set of remaining arguments, leaving the closure code block inside the braces. Well, let's look at a simple example as an aside before I come back to this project. Let's jump to the next page, and it's a playground page that has been set up using a SwiftUI view struct in the playground. If you're not seeing the canvas, you can select that option from here. Now, don't worry about how I set this up. I'll leave a link to my GitHub page in the description below that goes through this in some detail. When we run the playground, we see that our view is a simple text view inside a navigation view with a title displayed. Well, what I want to do is split up this hello world into two text views displayed vertically. Well, if you've been working in SwiftUI, you'll know that this is very easy. All we do is type vstack with some braces, and then within the braces we'll add the content that we want in the vstack, like this. Great, but do you really understand what's going on here? Let me copy the content within the braces first, and then delete it all, and I'm going to let code completion generate the code for me. vstack is a function call that has three arguments: the alignment, the spacing, and as you see here, it's a trailing closure called content. For the alignment, I'm just going to choose center. And since spacing is optional, let me set it to nil. The content is something that conforms to the view protocol, and it is just what I cut out from that simpler version. So let me paste it in. My preview then is showing exactly the same thing as my simpler version that we started with, but it looks so different. But it presents the same results. Let's deal with that last argument first. It's a trailing closure, just like we have seen. And what I said was that you can remove that argument name altogether so long as we move that closing parentheses from after the brace to be after the last argument before the closure. Well, let's deal now with these two arguments. If I drill down into the documentation for VStack, I can eventually get down to the init for the VStack, and I see that there is a default alignment of center and a default spacing of nil in the initializer. So this means that my specifications for these options in our VStack are redundant. So let's remove them. And since we have no arguments to pass in, we can remove those argument parentheses. There we have it, just what we started with. Returning now to our playground, there's one more option that we have for our say hello function call. What we've been doing is inline closures, in that we're creating our closures in line. Well, we don't need to do that. Let me create a variable that is a closure, like this. Let really say it. That's a closure of type where we have an argument of a string that returns nothing. And for the body, I'll call the argument name and print out hello name. Now we could use this in our call to say hello without using the trailing closure syntax. So I'm going to comment out that earlier option. The first option is still the name we want to pass in. And the second argument is the complete closure. And it has a type that expects a string and returns void or nothing. And this is what we just defined for really say it. So I'll just pass in that object. Now there's one more thing I want to cover on this that you will have likely encountered, and that's what's called a escaping closure. I'm going to copy my say hello function from the previous example here, along with that trailing closure call. But I'm going to do one more thing. I'm going to delay the call to this finally say it closure, and I can do that by enclosing it in a dispatch queue.main.async after block like this. Well, look closely at this. This is a function call that has two arguments. Deadline, which we can say is now plus 3 seconds to delay 3 seconds. And look at this. This is a trailing closure called execute. It has no parameters and returns nothing. So by hitting enter on our keyboard, Swift provides us with the trailing closure syntax because there are no arguments, and we get our braces here where we can add our code, which is our own closure call. This isn't much different from the previous example, except that we're delaying the time to execute the finally say it. But I get this error. Escaping closure captures non-escaping parameter finally say it. You'll often see this with asynchronous API calls, where the function is doing some calls that are going to take some time, and the closure will not be executed until those results are back. And what this is telling us is that the dispatch queue function is holding on to our escaping closure until 3 seconds are up. And the trouble is that our call to this function doesn't know this, so we could run into some real problems. And the solution is all we have to do is mark the function as at escaping. And now when we execute the code, we'll see that it delays 3 seconds and then prints out our greeting. Up until now, the functions that we've used have had parameters that are closures. What if we wanted to return a closure? For example, let's create a function called sayIt that has no parameters, but returns a closure of the type string returning void. Now remember, void is the same as a pair of empty parentheses. It looks a bit strange, but this is what the sayIt function is returning. In the body then, we return a closure. And remember, it's a simple pair of braces with some code in it. And since our closure has an argument, we have to give it a name, like name, followed by the word in. And then in the body, we can do what we want with that name, like let's print it. So how do we call this? Well, this is where the syntax gets really weird. If we just type say it with a pair of empty parentheses, nothing happens because we haven't provided any name to print. Now the name's not an argument of say it, it's an argument for the closure that is returned. Confused? Well, technically you can do this. And that works. However, you'll likely never see anything like this. What is common practice is to assign the sayIt function to a variable, like this. Let greetings equals sayIt. Now it's a bit cleaner because when we option click on greetings, we see that it's a closure that requires a string argument. So we can just type in greetings followed by whatever name we want to pass in. Now this is getting to be some pretty heady stuff. One more thing. For our last example, let's take a look at what it means for a closure to capture a value. If you use any external values inside your closure, Swift captures them and stores them alongside with the closure so that they can be modified even if they don't exist anymore. And what does that even mean? Well, let's create a function called counter that returns a closure that has no parameters and no return. So our basic building block then looks like this. Well, before the return then, let's create a variable called count and give it an initial value of 1. And then in the body, I want to print what the count is and then increment that value. Well, I'm going to create a variable now called GameCounter that's an instance of counter. And we can execute that closure simply with GameCounter. Now the first time we execute this GameCounter, it returns a function which assigns 1 to count and then prints out that value and then increments the count. Well, what happens if we call GameCounter one more time? Well, we're not creating a new instance of counter, and closures are reference types, so that when we call this one more time, it's captured already the value of count, which was first created, and the only thing that GameCounter is going to do is, when we execute the closure, it'll print out the current value of count, which has been incremented in the previous call, so it's 2. Well, these last two examples are pretty advanced, and you may not be using these techniques yet in your code. But if you ever look at any of the open source code available to you, and you should, you can see how others are coding in Swift. And you should now be able to have a better understanding as to what they're doing in some more advanced techniques. Now, before we go, remember when I first introduced the playground, I referred to this function? And this is what I used to contain all of my code examples, and each printout had a separator displayed before the title in the debug area. If I start to call this function, I see that there are 2 arguments required, one being a string and the other being a closure that has no parameters and returns nothing. Well, this is a trailing closure, so we can add a value to our string argument and close the parentheses and start our braces. Well, this is how every one of my code examples were presented. Behind the scenes, then, what is happening is I'm passing this code into the code function, and what does it do? It prints a divider, and then it prints the string results for, and then uses the string that I passed in, and then it runs whatever code I used for my closure. The trailing closure is often called a completion handler, and I have another video that focuses just on that type of closure, and I'll leave a link in the description below. It will serve as some reinforcement to this video too.